Today we will continue our discussion on section 4.1, and we will start by talking about how to draw angles in standard position. To think in radians means determining what part of a complete revolution or how many full revolutions will produce the given angle. For example, we know that one revolution or one full circle is equal to 2 pi in radians. So if I have an angle in standard position, remember standard position means one part is fixed on the positive x-axis and it rotates around the circle a full amount. That is 360 degrees, but it's also 2 pi in radians. And remember, if we talk about the coordinate plane, and remember we have the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant, that this would be 90 degrees, this would be 180 degrees, 270 degrees, 360 degrees. But in radians, and remember to convert, for example, 90 times pi over 180. So in radians, this would be pi over 2. In radians, 180 would be pi. In radians, 270 degrees would be 3 pi over 2. In radians, 360 is 2 pi. So keep that in mind as we're doing the following problems. Because, for example, they're going to be asking you to draw and label each angle in standard position. So, for example, if I want to draw and label a 5 pi over 4 angle, remembering that this is 0, this is pi over 2, pi, 3 pi over 2, and 2 pi. Well, 5 pi over 4, remember 5/4 is a little more than 1, but it's not more than 3/2. So I know 5 pi over 4 has to end up somewhere in the third quadrant here. And that would be my angle that I have. This is a 5 pi over 4 in radians angle. Likewise for part B, if I draw the picture, using the same guidelines that are over here, like pi over 2 pi, 13 over 4, well, remember, 13 over 4 is the same as 3 and 1/4. Well, if you notice, 2 pi is one revolution. So if we start here and we go around, this is just 2 pi. We still have 1 and 1/4 pi left. So we're going to have to go around again and end up in the third quadrant here, and that would be 13 pi over 4. So it is possible that an angle can do more than one revolution, or 360 degrees. So that would be a 13 pi over 4 angle. C talks about an angle that's negative. So if we look here, remember, negative direction means that we go the other way, right? So if we're talking negative, this would be negative pi over 2, negative pi, negative 3 pi over 2, or negative 2 pi. Now, if we're talking about negative pi over 4, well, pi over 4 is less than pi over 2, so we're just talking about an angle that goes just a little bit this way. So that would be negative pi over 4. And that's how we draw angles in standard position. Now, when we talk about coterminal angles, coterminal angles are basically angles with the same initial and terminal sides but rotated differently. For example, here is an angle that is rotated 120 degrees. All right, but I could also say that that angle is 360 plus 120. That angle is also 480 degrees. Whoops. 480 degrees. They are coterminal because they are rotated differently, but notice the picture is exactly the same. So that is the concept of coterminal. Also, if I wanted to throw a negative coterminal angle, you could say, if you went this way, that would be negative 240 degrees. That is also coterminal with 120 degrees. Now, if you notice, how did we figure out the first coterminal angle? We went 120 plus 360 degrees. And if you wanted to find a negative coterminal angle, you could go 120 minus 360. Notice 120 plus 360 gave us 480. 120 minus 360 gave us negative 240. So if it asks you to find a positive angle less than 360 that is coterminal with each of the following. So a 400 degree angle. Well, now 400 degrees is more than 360. So basically, if it's more than 360, what I'm going to do is subtract. So 400 minus 360, that gives us 40 degrees. That is a positive angle that is coterminal to 400 degrees. And if I subtract 40 from 360, I'll get a negative 320. And that is also coterminal to 400. So I found a positive angle that is less than 360. That's coterminal. And in this question, it didn't ask you for the negative one, so I'll just erase that. It only asked you for the positive one. Now in part B, it's Sophana wants a positive angle that's less than 360. So if it's negative 135, I have to add 360 to get a positive angle. And when I add 360 to 135, I get 225 degrees. And that is my positive coterminal angle less than 360. Meaning if I drew the picture, they would look exactly the same. The next one talks about if it's in radians. And remember, 360 degrees is equal to 2 pi, right? So when we deal with radians, instead of adding and subtracting 360, we're going to add and subtract 2 pi. Well, 13 over 5 is more than 2 pi because it's 2 3/5. So when I do this, I'm going to subtract 2 pi. Now remember, when you subtract, you get a common denominator. And remember, if we multiply by 5, we get 10 pi over 5, which means that 3 pi over 5 is the coterminal angle. Likewise here, we get negative 17 pi over 6. So whenever it's negative, to get it to be positive, we're going to add 2 pi. Well, when we add 2 pi, remember getting a common denominator, so we multiply by 6, so we get 12 pi over 6. We still get a negative 5 pi over 6, and remember it wants it to be positive. So we're going to add another 2 pi until we get a positive answer, which means it's 7 pi over 6. And that is coterminal to negative 17 pi over 6, and it's positive. The next thing we're going to talk about is finding the length of a circular arc. Now, a length of a circular arc is defined because remember, in radians, our angle was the arc length over the radius, correct? Well, now to find S, we just multiply by the radius, and that's where you get your equation that the arc length is equal to the radius times the angle. R is radius, theta is your central angle. So when we talk about, and so notice here, if I drew a picture of it, this is your central angle, this is your arc length, and this is your radius. So if I get to this next problem here, it says a circle has a radius of 6 inches. Find the length of the arc intercepted by a central angle of 45 degrees and express the arc length in terms of pi. Well, in order to do this, the first thing you need to do is convert from degrees to radians. So 45 degrees times pi over 180 is equal to, well, 45 goes into 180 4 times, so it's equal to pi over 4. So then, now you use the formula. So you use the fact that arc length is equal to theta over, or times r. Remember, theta is your central angle, and that's pi over 4. R is your radius, and your radius here is 6 inches. And pi over 4 times 6. Notice 2 goes in there twice, 2 goes in there 3 times. So it's 3 pi over 2 is your arc length in terms of pi. Hope you enjoyed our video today, and I will see you guys in class tomorrow. Have a good day.